St. Louis University researchers have discovered some of the molecular processes that lead to decline in patients with progeria. Their work also explains why certain drugs seemingly rejuvenate progeria cells, which could hint at more potent therapies against progeria. Hutchinson-Gilford progeria syndrome is a rare genetic disease that causes premature aging. Rapid aging of different tissues causes death by teenage years, normally due to cardiovascular complications. Currently, therapies for this devastating disease provide patients minimal benefits. The origin of progeria is a mutation in the lamin A gene, responsible for fabricating structural proteins that help keep the cell nucleus sturdy and the genome intact. The mutated lamin A protein, progerin, destabilizes the cell nucleus, causes DNA damage, and ultimately leads to the aging effects found in patients with progeria. Now, the researchers have delved deeper to understand how progerin wreaks damage at the molecular level. The team recently discovered that progerin damages DNA by hindering replication. This stress is sensed by special proteins like cGAS and STING that activate a type of immune response that leads to cellular decline. Interestingly, this response is activated without the release of inflammatory molecules, like interferons, that typically trigger the immune system. That appears to confirm that progeria's aging effects are, genetically speaking, an inside job. Treatment with calcitriol, a form of vitamin D, rescued cells from the progerin-caused glitches in DNA replication. That result clarifies calcitriol's previously reported role in repairing DNA damage and slowing progeria cell decline. And it encourages a second look at the drug in exploring treatment options for patients with progeria, an area where the research team is quickly gaining ground. In a separate study, they report how a high-fat diet can vastly improve progeria mice, namely by doubling their lifespan, the largest extension of life ever recorded in these mice. That added time allows the more human-like traits of progeria to develop. The results suggest that metabolism might play a more important role in disease pathology than previously thought, and that nutritional approaches could be powerful therapeutic tools in both mice and humans. Altogether, the team's work is refining the picture of how progeria develops and progresses, from its molecular beginnings to the expression of hallmark traits in mice and humans. Though further research is needed, the findings could clear the way to better, more targeted approaches to battling the damaging effects of progeria.